Hey there, Mike. What's up?
Not too much. Um,
Hey, it seems like I just talked to you
we
the other
don't.
day. Did I talk to you the other day?
Yes. Yeah. We got our ass to Mars. No, we didn't.
No.
What did we do?
We went up in the shuttle.
Oh, sorry. We went up in the shuttle. That's cool. People will hear about that soon enough next week. But there's goodnesses for this week. God, it's like I feel like we've just been doing so many Kickstarters and this is and that's is that the science has been falling behind, and I feel like we're about to catch up, which
Yes.
is awesome. We do every show. We always have a little word science, don't we?
Yes. Yes.
Word science. So this is a little bit different. Once in a while, we just like to flip it up a little bit. I just not do toilety words all the time. So I have actually a little challenge for you, my friend. This is starting with 1900 and going for. I am going to give you a word, and I want you to tell me if you can define that word. These are words that were used 1900, 1910s, 1920s. All right? So I want you to see if, and obviously it'll seemingly get a little bit easier as we go along, but, let's see. Okay? Here we
All
go.
right. Just as long as we burn through it, 'cause it sounds like you got a bunch of words.
Uh, I believe it's 10.
Okay.
Here we go.
I'm sorry. What was that again?
A goop.
Goop. Is it
Goop.
kind of like a goober type person? Would it be the same thing as a goober these days?
You know what? I'm going to say yes.
Okay.
Look at Peter there. He's such a goop. A stupid person. Okay, there we go. 1910. Duck soup. Certainly use this in a sentence for you. All right. For me, doing this podcast is duck soup.
A huge pain in the no. A relief. Something uh, intellectually stimulating.
No. Something easy. Duck soup. That was in the 1910s. Yeah, see, boys, we're going to do this and it's going to be duck soup. We're going to rob the bank and it's going to be duck soup, see? Yeah. All right. Don't ask me why. I just read them. I don't.
I think wasn't there a Marx Brothers movie called Duck Soup? I believe.
There was.
Yes. Okay.
Yes,
All
there
right.
was.
That's right. All right. Let's go next one.
All right. Hey, Pete, butt me.
But you. Oh, I know what that is. That's give you a cigarette.
Button. Yeah, see? Give me a cigarette. Yeah.
Yeah.
Yes. All right, here we go. 1930s, moving on. Dog soup. Hey, Pete, why don't you pour me a glass of dog soup?
That would be crappy uh like what would they call it? Bathtub gin, like bathtub alcohol, right?
You would think so, but no. Ironically, dog soup is water, the exact opposite. But I think you were in the same vein. You were thinking around those terms with prohibition and all
Yes.
that good stuff. And on to the 40s, my friend. Oh, Jesus Christ. Hold on a second. I got to get close up. That's right. Okay. Ducky shin cracker. Boy,
Midget? I don't know. Little person? What is it? Huh?
I can't wait to get to the club and see Pete. He's a ducky shin cracker.
Good dancer?
Are you fucking kidding me? Yes.
Oh.
That's it. Good dancer. Yes. Awesome. Good job. All right. Boy, don't. You need to leave me alone. I am quite frosted right now. This is the 1950s we're into, by the way. I am frosted.
Frosted. Angry? Would that be like you're pissed off about something?
Yes. And I mean, I would like to think that my intonation is giving you the hints, but yes, you are absolutely right. I am frosted. On to 1960. Submarine races.
And this is not dirty, right? Not you're saying these aren't dirty.
But
Okay.
as dirty as it can get in the 1960s, I guess.
Okay, I was gonna say because I could think of submarine races like. Never mind. Submarine races.
Uh,
Uh,
hey, Pete, something that would be appropriate is say, if I drove you to the water and we watched the submarine races together. That wouldn't be appropriate for the 1960s. Certainly, it would be appropriate now. Nobody should have any problems with that now. But yes, submarine.
all right, you got me. I don't know.
This is the king out.
I'm sorry.
Come on.
Say that again.
It's the excuse you give to a girl. You say, "Come on, I'm going to take you to the submarine races," and then you park next to the water, and you say, "We're going to watch the submarines race."
Right. Okay.
Is there? Yeah. Okay. No.
I got it.
1960. Here we go. Stop dipping in my Kool-Aid. Hey man, you gotta stop dipping in my Kool-Aid, man.
Is that like harsh in your buzz?
No. No.
Is it? I don't know. Go ahead.
Get out of my business. Stop dipping in my Kool-Aid.
Gotcha.
Now we're moving on to the 80s, and they were so easy. This was the only one that I could think was. They're all easy. I'm sorry. We're all. Anyway, here we go. Barf me out.
Oh, yeah. That's to make it like gross you out or something. You know, something you'd hate. Like, oh, it's so terrible. Barf me out.
Now, pretty much, I think the 1990 like loops back around almost when we call somebody a scrub in the 1990s. That was pretty much, they could be called a goop, which
Right.
I'm not even gonna. I mean,
we know
obvious.
this one. Go ahead.
That's that.
Okay.
So just thought I would hit you with words, popular vernacular from 1900 to 1990.
Nice. All right. Let's start the shoe. Well, I got to put it on me. All right. So, in the beginning, God pulled his finger and Dutch ovened the universe. And all you got was the MythWits. The show dedicated to all things geek pop culture drenched in absurdity. Coated with sarcasm. Every week, we bring you the news and interviews from the Geekoverse. We do our damnedest to be funny, but there are no guarantees. I think that one was actually a little bit funny. I'm your host, Peter Bryant. And joining me this week are my co-hosts, Michael Kafis, special guest host, Brian Gregory, and
What's up?
Our host this evening, or not our host, our guest, sorry, the other word. Our guest this evening, Ethan Siegel.
Hi, it's great to be here.
Hey, welcome to the show. Ethan is a theoretical...
Most epic beardage.
Yeah.
You are damnedest.
No doubt. Ethan is a theoretical physicist, astrophysicist, who loves writing long, glorious illustrated articles that tell what we know about the universe and how we know it. He's been writing the blog Starts With a Bang since 2008. It's an excellent blog, and it's currently at Forbes. If you're into astronomy, he writes a monthly column for NASA's The Space Place that appears in over 200 Astronomy Club newsletters worldwide. His very first book, Beyond the Galaxy, is available from World Scientific. If you ever want to know the entire story of the universe, is how it's made, of the universe is made of, how big it is, where it came from, and what its fate is, and how Pete doesn't know how to read, told in plain English with no equations, you'll definitely want to get yourself a copy.
How big is
right? When Ethan's not writing, he can be found appearing on TV and radio spots, teaching at Lewis and Clark College, broadcasting Starts With a Bang podcast on SoundCloud, working with various science museums, and in general sharing what we know about the universe with anyone willing to listen. All right, that's enough of that. I'm sorry. I'm a tiny bit fried. My daughter woke me up last night with the
Shankers?
No, we don't say dirty words.
Bottle
on the
liquor?
show. No, she had diarrhea really bad. And
Oh, sorry.
if she was older, I wouldn't say that.
I'm trying
but
to figure
she's-
out your
she's-
gesture.
Yeah, in a couple years, she'll look back and be like, "Dad, I can't believe you said that." But yeah, she woke us up, and I've been up a long, long time. So
Are you saying that her tussie threw up? Is that what you're saying?
yeah, her tussie threw up. So you might recognize Brian from one of our previous shows. We called him Brian Bot because we had the other Brian on our show at the time. And Brian just, he's been busy with stuff. So He hasn't
Stuff
been on.
and things.
Yeah, stuff and things.
The other Pipes, Brian Pipes, not. But so we thought we'd have Brian Bott back.
Brian Price, Brian Robot.
Right, but this way I can just say Brian. So, Ethan,
Yeah.
you know a thing or two about the space.
That's what they tell me, and I'm sorry for giving you such a long bio. You said a paragraph, and apparently I write a little bit more than I think I do. So next time you say paragraph, you're getting 2 sentences and no more.
Well, it's my own fault. I bet you if you look on the YouTube, I usually put the bio in there as well. If you look on our YouTube page, and it's shortened, right? I know I edited it, but in the notes, my show notes, I had forgotten to get back to it. I dumped the original in here. I didn't get back to the edited version, and I'm reading through it. I'm like, oh shit, I forgot to edit this one. Oh well, too late now. So I just read it. So welcome to live show, folks.
That's how we do it. If it makes you feel better, the very first time I ever gave a science talk anywhere, I got introduced by a Fermilab physicist. He's pretty famous in physics circles. His name is Joe Licken. And the introduction I got from him was, and now for our next speaker.
Well, I made
that was it. That was the entirety of my introduction, my very first presentation to another group of professionals. So,
well, now you can tell. Now
you couldn't do worse than that.
You could tell everybody that I made up for it.
You're just going to average them and
Yes.
get 2 perfect introductions.
Exactly. So I guess my first question is I don't hear anything because my headphone went out. All right, I hear that space is big. How big is this?
Mind-bogglingly big.
Yeah, I think that's why they call it space. How big is this space?
I mean, I feel like I'm on Match Game now. Right. So how big is it?
Is it?
So when we talk about space, what people talk about, there's one of 2 things that we talk about. The one that we look at is we say, well, how big is it to the edge of the universe that we can see? And that actually has a number, right? The universe, we say the part that we can see, it began with the Big Bang, and we can calculate how far back did that begin. That was 13.8 billion years. So you say, oh, well, I know how that works. Things move at the speed of light, so it means it's 13.8 billion light years in size, and that's wrong. Right? Because that would be too easy. So what happens is you have the expanding universe. That's the big thing you get out of general relativity, is that you don't have this fixed grid of space. Same space, the fabric itself can expand, and this is why all the galaxies are moving away from all the other galaxies. The farther and farther we look, we see things are moving away from us faster and faster. So we figure out how fast they're moving. We do all the math. 46 billion light years is how far we can see in any direction. That's as far as we can see. But then people say, well, what's beyond that? Does it just end? Does it loop back on itself? And the answer to both of those is no, it doesn't end. It doesn't loop back on itself. How much farther does it go on? Well, we don't know.
Right.
Based on what we observe, it's at least 250 times in all directions what we can see.
Wow. Okay.
So it's at least that big.
So there's the universe. There's the universe, and then there's the known, the what can be known universe.
Yeah, I like to call what we have accessible to us. That's the observable universe.
Right.
And then everything else I'll just call the universe.
I got a quick question. Why the 250 times?
Okay, so what you can say is, I can imagine, right, that maybe, like, you can make the argument to me like, well, the Earth is flat. I'm like, well, why do you think the Earth is flat? And you go, well, because I went out in my backyard and I did everything I could to measure the curvature of the Earth, and it's not curved, right? I went over here in the backyard, and then I went over there in the backyard, and everywhere I went, I stuck, stakes in the ground, and I measured shadows from the sun, and everything looked the same. And I say, yeah, if all you had was access to your little corner of your backyard and said, I'm going to measure the curvature of the Earth from that, you can't. But what you could say is, if the Earth, if it loops back on itself, it's at least this big, to the limit of what you can measure. And you wouldn't get 400,000 kilometers around, you would get like a few hundred kilometers around. Because if it was bigger than that, you wouldn't be able to measure it. Well, we can kind of do the same thing for the universe. We can say, hey, I'm going to look at that distant galaxy over there and that distant galaxy over there, and I'm going to make a triangle. And if the angles in that triangle added up to a different number than 180 degrees, some measure of how the universe was curved. If you get exactly 180 degrees, then that tells you the universe is flat to as good as you can measure it.
Right.
So that's what we do, is we look at all these different sources and we say the universe is flat to as good as we can measure it. How good can we measure it? And the answer is, well, about 250 times as big as Earth. So that's how we know if it loops back on itself, it's got to be at least that big.
Wow. That's a new one for me.
Neat.
Wow, that's cool.
Neato.
I hope that was understandable.
Yeah.
I worry about that.
Yeah, my brain broke just a tiny bit, but I think I got the gist of it. And that's something I a lot is I'll get into some of these things and I'm following, and at some point it just kind of goes boop, 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 boop. My brain breaks, and I'm just like, oh man, I had it. I really did have my hand. Like I read the Elegant Universe by Green.
By Brian Greene.
Brian Greene. That's the word.
Yep.
It's a long time ago too, so it's been a while. And I got mostly through the book and was like, okay, I'm getting this right. I'm following. I'm digging. And I got to some point and I was just kind of like, I was like, look, I understand words you're saying, but my brain can't. I'm not like fully understanding this. Like I get it. I get what you say, and I'll accept that what you say is cool, but I don't really know what it means. But that's okay because that's like, I mean, I don't know. He's talking about string theory and stuff, and I was like, but yeah, I get most of it. I will tell you one thing, and it's something I want to ask you about because I think it's something that a lot of people don't get, and it's actually easy if you describe it properly, is the theory of relativity, because I think that's very important to everything that we talk about when we talk about space, because relativity plays such a big portion on it. And I want you to correct me if I'm wrong, and I usually am. Whenever I talk to an expert in something, I realize just, like, oh man, thought I had it. So my understanding of relativity is basically this. Everything is traveling at the speed of light. Okay, everything. But the faster you go in distance, the slower you go in time. Is that how that works? I mean, am I getting that right?
That's a fair way to look at special relativity. And I like that approach, by the way, your approach of saying like, hey, I think I understand something. Let me explain it to you in my own words, and then you can tell me where I've gone wrong, if I've gone wrong. Or if I'm right, maybe you can tell me how I'm right.
Yeah.
And that's fair too. So let's go with that. So yeah, here's the thing is if you move, right, this is the whole problem where the twin paradox is the famous problem in relativity, where you and your identical twin are both on Earth, right? There's you and then there's good Pete, right? And so you put good Pete in a rocket and you say, good Pete, we're going to send you, 10 light years away. And you're going to go fast. You're going to go at like 98% the speed of light. So good Pete gets in his rocket. He goes 98% the speed of light, lands on Earth. He goes 10 around you. It's been just a little over 20 years. Okay. So you're 20 years older. But for good Pete goes away, comes back. He's only like 2.5 years older. And you say to him, hey, good Pete, what happened? I saw you go away, you came back, you're young, but how did you go 20 light years and you're only 2.5 years older? And he says, it wasn't 20 light years for me. For me, it was only a little over 2 light years. I traveled less distance. So that's the deal, is because good Pete moved relativistically relative to you, he went through less space for him and less time for him. But to you, he went through all of that space. Therefore he went through less time.
Oh,
so that's it. You can go through a certain amount of space or a certain amount of time. You went through more time and he went through more space.
So this is why the movie Interstellar really messes me up.
Ooh. Yeah.
And also why I was so excited.
Did you have? I think it's really too bad with video because I got to see you, Pete, and I think I got to see the exact moment that I lost you, where you did exactly what you described, where you had it up to a certain point, and then you lost it.
Now this is rare for Pete and I. Usually, if Pete's brain breaks, mine has been broken for quite some time. But I am just what you're saying as a rule and just saying, okay, well, then that's how it has to be. If I go through more space faster, then I'm going through less time. Then that's just the rule. And if someone's going through more time, less space, then that's the rule. They can't go through more space.
And so here's a fun thing. Let me ask you this then, because I think you got it, because you're just accepting the rule.
Right.
The maximum speed is the speed of light. So if I shine a flashlight and I say, hey, photon, thing from the flashlight, you went 100 light years in one direction before you smashed into something else. How much time passed for you over that 100 light years? You went at the fastest possible speed. How much time passed for you?
Zero.
That's right. So time stops passing if you move at the speed of light. For those of you who are Star Trek Voyager fans, this is why Tom Paris broke the universe when he hit warp 10.
Ah, right.
So basically,
right. But hold on, I'm on the edge of breaking here for a second. Even though we see light that's hitting the Earth from a star that's, say, long since dead, right? That star has been occupying the same spot, not moving much, and it died. But the photons, did they instantly go from that star to our eyes?
And that's a great question. The answer is it depends on who you ask. If you ask the star or if you ask us, we say, nope, it only moved at the speed of light. So if it's 100 light years away, it took 100 years to travel here. But if you ask the photon says, everything happened for me instantly. I was created and emitted, and then I arrived. And it was the same instant. It was all an instant for me because I don't understand time. Time doesn't exist for me. I move too fast.
See, I get that. That I get.
Wow.
I mean, that makes perfect sense to me and always has. Well, not always has. It has since Brian Greene's book. But that was when, I started using the line, people say, and I don't want to make any judgments on whether anybody's religious or not or whatever. But for me, because I'm not, but when I try to explain, people say, well, don't you miss out on the beauty of the universe, like the beauty of everything? And I'm like, hell no, I don't. I'm like, you know what's beautiful? You know what's beautiful? That star right there, that one that's 100 light years from there. The light that's hitting my eye traveled 100 years to get to me. And guess what? It's not a second older than when it left. If that's not beautiful, I don't know what is. And that's where I get excited. That's where
certainly
I feel,
is
yeah,
mind busting.
Yes. And and it's like, and if you want to throw some kind of spiritualness on it, it traveled just to get to me. Okay, there you go. I know it didn't, but if you need that, then I'll throw that on there.
So 100 years ago, Mike, the light from that star, they're getting our, like they look at us and they see us 100 years ago. So what are we saying here on Earth? Go to someone 100 light years away?
Right.
Is this the test question? Yeah.
I mean, you just told us what people were saying in the 1910s.
Oh, what was
in
it?
The 1910s.
What was your 1910 word,
one?
Mike?
Come on, it wasn't the bee's knees. It was something that meant the bee's knees. What is it?
Goop? I don't know.
No.
That was duck soup.
No, not
Duck soup.
Duck soup.
Duck soup.
Yeah, right.
Duck
Sorry.
soup is easy.
Yes, duck soup.
It was this light's gonna go there. Bada bing! It's duck soup. Wow! Look at that, Mike. You stumped us on our own word. Oh, it stumped you on your word.
No, so all right, you know why? Because what I'm trying to do is fathom this. Okay,
Your brain is still trying to wrap around the light.
light from our, let's just say, conceivably, some emitting lights, and I mean, because radio transmissions travel not at the speed of light, right? Or
No, they
No, they are.
They do.
Radio's a form of light.
Yep.
Okay, all right. You know what? You're absolutely right. So radio transmissions are reaching, the Schmegma galaxy far, far away, and the Schmegonians say, "Oh my God, look, we love that show. We want to see that." They can travel faster than light, but they will not be able to get here in time. Or will they be able to travel in time to see or even have that when that was happening or not? Because that whole space travel thing, what would need to happen for them to have this instantaneous / long time light years that this radio transmission took to get there, but then they can instantaneously, what would they have to have for them to
Right. So what you're asking is, too far away, right? So someone says, "Oh my God, I'm on a distant star. I love Lucy. I want to come back to Earth and I want to watch I Love Lucy being filmed. I want to see Desi Arnaz in all his glory. I want to see Lucy with her red hair in black and white. I want to know what this is all about." And so they go as close to the speed of light as they can, and they get here, and you go, "For you, buddy, I got some bad news about Desi and Lucy." And you're like,
They're long.
"Oh, hold on, we're gonna do this again. What can they do to get back here in the 1950s, even though they're receiving the signal like now?" So you're right. You have to do something to cheat the laws of physics. And how do you do that? How do you go back in time? You said it is one theory, is maybe you can go faster than the speed of light. If you go faster than the speed of light, then maybe that can bump you back in time. But what you're asking me is, hey, physicist, so these laws that you play by, what if we just broke them? Then what would be different? And the answer is yeah, well, anything you want, just how do you want to break them? And yeah, go faster than the speed of light. Why don't you just poke a hole in the universe and come out at a different time? That'll work too. Go ahead, knock yourself out.
Ethan, we'd like to get there a little faster. You could make that happen. That'd be great.
So they would get here.
Hang on,
they get here and they'd
let
say,
me get my
"I want
my relativistic GPS report. We'll make it happen."
They'd get here and we'd be like, they'd say, "I want to see the I Love Lucy." It's like, we got some splaining to do. So, no Lucy.
We'll see.
Yeah.
Yeah. But if they could go faster than the speed of light, but they overshot it, they could conceivably get here before Lucy's born. Then they have to wait.
Right. Okay.
Yeah.
So let's move on to dark matter. So dark matter is one of the things that I know very, very little about. Dark matter and dark energy. I have the basic concept. Dark matter is this matter that we can't perceive, but we know it's there because we can measure it indirectly, right? I mean, that's my understanding.
That's good. Yeah.
Yeah, because it has mass, right? We know it's there because it's affecting gravity. And it's not dark. It's just that we can't see it, so that's what we call it, right? We know it's matter because
a better name for it would have been invisible matter.
There you go.
Because anything else you can say, "Oh, this is matter and this is matter." Well, if I wanted to interact with it, I'd just smash it into each other and boom, I can do something with it, or I can shine light on it, right? And then I can see it because it'll reflect light or absorb light or whatever. You can't do that with dark matter. Right. So dark matter, it's really weird. The first evidence for it showed up in the 1930s. There was this astronomer, this Swiss-German dude named Fritz Zwicky, which is a pretty good name, Fritz Zwicky. Okay. So Fritz is he's looking at the densest, richest cluster of galaxies that we know, the Coma cluster of galaxies. This is a cluster, it's about 323 million light years away, and it's got 1,000 times the mass of the Milky Way in it. So thousands of galaxies in there. And what he's doing is he's watching these galaxies. He's saying, okay, some of them are moving this way and some of them are moving this way. Some of they're moving either towards you or away from you. So what's going on here? And he says, well, hang on. I know how the laws of gravity work. So if I see these galaxies swarming around like a group of bees, then I know the thing holding this together is gravity. So how much mass has to be in there? And he gets a number and says, okay, if these things are all in a bound cluster and they're moving around at these speeds, here's how much mass has to be in here. And then he says, well, hang on, but I'm also an astronomer. and I can measure all the stars, and I know how stars work because I'm a good astronomer. So if I measure all the stars, then I can say how much mass is there from all the stars, and I can get a number. So let's get these two numbers and let's compare them. And if you do this today with the best technology we have and the best understanding of stars and galaxies and gravity that we have, these numbers miss by a factor of 50. The number of stars you see accounts for 2% of the mass that needs to be there. So that's lousy. That means 98% of the mass that's there, stars. Solar system, you're like, well, crap, it's all the sun. That's 99.8% of the mass in our solar system. So what gives? Some smart guy comes along, smart whatever, comes along and says, hey, there's other stuff. There's black holes, there's planets, there's dust, there's gas, there's plasma, there's all this other stuff. And you're like, yeah, there is, and we can add it all up. And guess what? That'll get you from 2% up to like 17%. But you're not getting more than that. So you've only found like 1/6 of what's out there. What's the other 5/6? And the answer is dark matter. It's some type of matter that isn't made up of protons, neutrons, and electrons, isn't part of any known particle, but we can see its gravitational effects. And we can see it from a whole bunch of different things. We can see it from the way that distant starlight bends around galaxies. We can see it from the fluctuations in the leftover glow from the Big Bang. The best way we can see it is every once in a while we get two big galaxy clusters that will collide together. And what happens when they collide together is, the little stars, they're like if you took two guns full of birdshot and you fired them at each other, they go right through each other, right? You almost never get a collision. But the gas, everything that you can't see inside, all this normal matter, it heats up. It undergoes friction with each other. It heats up and it starts emitting X-rays. So even though these individual galaxies pass through each other, all the gas within them gets stripped out and emits X-rays. And we can see the X-rays thanks to the Chandra X-ray telescope and other X-ray telescopes like that. And then what you do is you say, okay, but I know how the mass bends the starlight, so where's the mass? And the answer is the mass has passed right through. Has passed through about 80 to 85%. That's dark matter. Right. So that's how we know, yeah, there's some type of matter out there. And you can also do other ways too. You can look at the rotation curves of galaxies and there's dark matter, and you can look at interacting pairs of galaxies and there's dark matter and a bunch of other things. But that piece of evidence is a big one. And we've got it for little groups of galaxies and giant clusters of colliding galaxies. And we've got like a half dozen, maybe even more at this point, that all give the same numbers. So, wow. I'm a dark matter fan. And I was skeptical of it originally, but I think anyone who's been paying attention since maybe 2003 is kidding themselves if they think that dark matter is not the best explanation for what's out there.
Unobtainium.
What I love is
that is not the first time I've heard that. It's right there on the periodic table.
What I love is that we're all sitting here, right? And you're talking, and the three of us, I don't know if you guys noticed this, but the three of us are going like this. All as you talk, we're all going, because that's definitely worthy.
It's beard envy.
Yes.
It's got to be the beard envy.
Totally.
It's definitely
so
brain envy.
I have a question.
Okay, Mike, go ahead.
What I want to know, can they, are they, this is what I'm hearing, is that they're starting to conceive like the shape within the universe that dark matter is having, and they're starting to conceive that it's, if I'm not mistaken, tendril-like, that it actually goes out in tendrils through large swaths of space?
Yeah, so this is, I want you to think about, like, I want you to imagine, and this is like a very difficult thing to imagine, so I'm gonna ask you to just do your best here. Start off with a universe that's almost perfectly uniform in density. So I want you to imagine that, like, the densest part of the universe is like 0.01% denser than average. And the least dense part of the universe is like 0.01% less dense than average. So you start with it like these little, it's almost like if you imagine an ocean as seen from like afar, the ocean looks flat. You're going to find there are some places where the waves rise and there are some places where the waves sink, and it's this imperfect place. That's about how imperfect the universe's density is when it starts off. It's about as the imperfect flatness of the ocean compared to the depth's its deepest point. It's almost perfectly uniform, but think about the way gravity works. Active force, but it gets better over time. So if I'm just slightly better than average in terms of density, I'm like, hey, come here, and I'm bringing more and more matter to me a little bit. But the more I get, the better I get at drawing more and more matter to me. It continues over time. So there you reach a point eventually where you've got so much matter that you're really, you're sucking it in good now. You're like, yeah, I'm really running away with the show here. And before you know it, you're a big enough clump that you start forming stars. And the other clumps that start forming stars that are around you, they start seeing you and you're like, hey, come here. And they're like, yeah, you come here too. And you meet up and you start forming galaxies. So what does this look like? Well, you can imagine a thin network of like filaments. One clump and another clump, they come together along this filament. And where the filaments all meet, where you get the densest parts of the network, that's where you form the biggest structures, the galaxies, the clusters, the large-scale structure of the universe. And this is what we've started to call the cosmic web. If you look out and say, what are the largest structures in the universe? They are these galaxy clusters, but galaxy clusters themselves seem to be clustered along these filaments. Great walls in the sky. The first one was discovered in the 90s, and now we've got them. Now we've got even bigger ones, some of which are around almost 1 billion light years across. So very, very big.
You're frying my noodle, man.
Yeah.
You asked. Oh, he asked.
So, real quick though, on with dark matter, does dark matter, does it clump together like regular matter at all? Does it? Do we know? I mean, do we have any idea if it does or not?
Well, I mean, there are some things we can say. It does clump, but not like regular matter. So the reason that it forms these bound structures, there's two things that help. One is, normal matter. If you take normal matter and normal matter, it splats, right? It'll come together and splat. And that's what normal matter does because, you can take your hands and go splat. You're like, oh, yeah, like atoms and atoms, they stick together, they interact. That's good. Dark matter doesn't do that. But because normal matter does, dark matter can become bound to it. Oh. The other thing that happens is when you get a clump of matter, even if it's just dark matter that starts to get attracted towards itself and the universe is expanding, what you're going to wind up with is a big, diffuse, mostly spherical halo of dark matter. So when we say, hey, what does the dark matter look like around the Milky Way? The Milky Way is, we're like, oh yeah, we've got our bulge and we've got the spiral arms and it all comes out in a disk. The extent of that disk, diameter, end to end, 1,000 light years. And if you say, well, how's the dark matter distributed? We think from simulations, from observations, from everything we can tell, it's a big sphere, the whole galaxy, but it's about 10 times the diameter of the disk of our galaxy. So dark matter is much less dense. It's much more diffuse. And these dark matter halos are than the normal matter we're used to.
Wow. Okay.
So I got a quick question.
Yeah.
So essentially the definition of dark matter, it's something that exists, that has gravity. What else?
It doesn't It doesn't
But he-
absorb or emit light.
Okay.
It doesn't collide with normal matter, the particles in the standard model. So
Therefore, it wouldn't like produce energy when it collapses, and like if because normal matter when it comes together in large mass, you get energy discharge, you get other kind of interactions, right?
Right. And as far as we can tell, so there are 4 fundamental interactions in the universe. There's gravitational, there's electromagnetic, nuclear forces, the strong and weak nuclear forces. And as far as we can tell, dark matter does interact gravitationally, but doesn't interact through any of the other forces. Collide with normal matter, and it doesn't collide with itself. Which means if I don't know, if I had this suddenly turned into dark matter, what would happen to it? Well, not only would I cease holding on to it, and not only would it cease to hold itself together like the atoms do, but it would, through the floor, through the earth, and it would make an ellipse through the center of the earth and come back out, because
every
it
time
only interacts gravitationally, which means it will not collide with any other type of matter.
Fine.
I love it. I love it. Brains are going. Can you hear the brain cells popping? It's like bacon.
So
right now.
I've thought about this a bunch of times, and every time it's just
that's what's happening. It doesn't feel like it, but that's what's happening.
No, I am. I think this is great. I've learned more about dark matter than I've ever read at any time. It's awesome.
It's yeah.
I'm gonna plug you then.
There's something.
You're gonna love chapter 9, buddy.
Okay. Yeah, all right. Then I need to
I was just putting that on my reading list.
Yeah,
right?
excellent. So, go ahead, Mike.
Well, can you give us your dissertation on brown matter, because you are an expert at that.
In brown matter, did you say?
Yeah, Pete is. He would like to discuss
the philosophies of brown matter.
I think he's an expert after last night, and I'm sorry about that. That's no fun.
So Mike is my poop muse, just so you know. Anyway, no, all right. So look, I noticed. All right, so Ethan, you don't have a do you have a t-shirt? Do you have a t-shirt that has anything on it?
No, I wear plain. Okay. I wear plain solid T-shirts normally.
Okay.
I'll show off my whole fashion sense here. I've got a belt buckle, which is a flask.
Oh, I like that. Okay.
Oh yeah,
that's nice.
And I've got a kilt on. Can we see this?
Oh yeah,
Fantastic.
beard in the kilts. That's awesome.
So that is my fashion sense up here. Is beard, mustache, shaved head, solid T-shirt, belt buckle, flask, kilt, and that's what you get.
Fun.
That's what you get. Because you've only seen me dressed up for a con.
Yes.
You've never seen me in like street clothes.
Which is
so
fantastic.
You've seen me like days. You saw me at Balticon. If you saw me the 3 day, like all 3 days, I think you saw me as Rainbow Dash from My Little Pony.
Yep.
I think you saw me as
Triton.
As King Triton from The Little Mermaid.
Damn, awesome.
And I think you saw me as Zangief from Street Fighter 2.
Yes, that's when I first saw you as Zangief.
You did
yeah.
Yes.
Wow.
It was perfect.
Awesome.
Brian missed out on Baltimore.
I missed out on all this. Yeah.
Yes, you did. Well, the only reason I brought this up was because I was looking at. I was trying to see Brian's shirt. Get your ass to where? Where we going, Brian?
Oh, that's Buzz Aldrin's
nice.
shirt.
Fantastic.
Yeah.
Buzz Aldrin's shirt, man. That's
fantastic. And I've got my Skynet shirt on.
Yes. Which is appropriate.
I'm with
Cyberdyne Systems.
Although you're too late. It's way too late for that.
I'm with the machines. I see what they do to robots, Brian. I see what you guys do to robots, Brian. I'm watching, and I'm on their side. And Mike, what do you got there? What is your? Senior Frogs. I know that shirt.
Yep. Been there.
I got that shirt for you.
I have a yard around here somewhere. One of those yard.
All right. Well, enough
plastic
of
things.
the T-shirt break. All So then there's so before we get off this, because you're so good with the dark matter, dark energy. Now, dark energy is a different beast, right? It's not the same thing at all.
Yeah.
And my understanding is
No, it's not. In fact, the only thing dark energy and dark matter have in common is the name dark,
Right.
and that's probably a bad name for it. So I want you to maybe I'm like, this is what you should do during a video thing, right? Close your eyes, because I want you to picture the Big Bang as best you can, right? So what does a Big Bang look like? I want you to imagine this dense ball of matter and energy out away from each other.
yes.
But you know that you've got gravity working to pull it back together, right? Matter and energy, it's all expanding away on one hand, right? You've got this initial expansion of the universe. And then on the other hand, you've got gravity trying to pull it back together. And if I said to you, okay, this is what we start with. We start with expanding space. It's full of matter and energy, and gravity's working to pull it back together. What's going to happen, right? If you didn't know any better, you would just Goldilocks me, and you'd say, well, there's three possibilities, right? Either it's too fast. The initial expansion is too fast, and it's going to speed away from each other. All the stuff's going to speed away. Gravity's going to try to pull it back together, but it's going to fail. So things are going to slow down, but it's never going to stop, and it's never going to recollapse, and it's going to go on forever and ever and ever until everything speeds away from each other, and we have this cold, dark, empty abyss, which many of you will say, like, oh, it sounds like my life, right? So that's just what you get on the one hand. And then you say, okay, well, what if it's the other way, right? What if the expansion isn't fast enough and there is enough gravity? Well, then you say, okay, well, it's going to expand, and slow down, and it's going to slow down and stop. It's going to reach some maximum size, and then it's going to turn around and come back together, and boom, and the universe is going to end in a big crunch. And then you say, well, then there's the Goldilocks case, right? What if the universe is just right, where it expands and slows down and asymptotes, right? Where it looks like the expansion rate is going to approach zero, and it gets closer and closer and closer to zero, but it never stops completely, right? It's like trying to pay off your student loans, that your balance gets lower and lower and lower, but you never get out of that hole that you dug.
I knew it. The universe is compound interest. God damn it. No, okay, I'm sorry.
Cosmic inflation.
Right. Okay.
We'll get to that.
Right. Yeah. Okay.
Oh yeah, yeah.
All right. I'm sorry. Go ahead.
And so you'd say those are the three possibilities, and that's what astrophysicists did since like the 1920s, when they first started thinking about this. Right, the first person to conceive of this was a Soviet physicist named Alexander Friedman, and then later George Lemaitre did it. And in America, we give credit to Robertson and Walker, Howard Robertson, and I don't remember Walker, so we'll just say Herschel Walker. It's not Herschel, but it's fine. It was Herschel Walker. No. After he got traded to the Vikings, that was what he did. So, that's fine. We have these people said these are the three possibilities, and that was the goal of cosmology for a long time, is to measure which of these three possibilities it is. And finally, in 1998, we got the answer. We made distant enough observations of how things are expanding in the universe over enough time to say what's going to happen, and the answer is none of them. None of those things are going to happen. It looks like the Goldilocks case for a long time. It looks like things are slowing down and the expansion rate's dropping, and it's hard to tell, is it going to recollapse? Is it going to go on forever? We're really close to the border. And then all of a sudden, a few billion years ago, the expansion rate starts speeding up again. It starts accelerating.
Again.
And people are like, what? You must have done something wrong. That is not what we expect. You must have done something wrong. And for years, people didn't believe it, or they tried to do something else, and they had different teams working on the distant supernovae. They said, well, what if you threw the supernovae out? What other ways could you do? Can you look at the large-scale structure? Can you look at the clustering data? Can you look at the fluctuations in the microwave background? Can you use gamma ray bursts? Can you use distant galaxies? Like, what other distance indicators can you use? Good today that even if you threw the original data out, the supernova data out, that first indicated this, you would have overwhelming evidence, better evidence than we have for the Higgs boson, which we totally know exists, that no, this is really what's happening. So then you say, why? Why is the universe's expansion accelerating like this? And scientists say, let's give it a name. How about dark energy?
Nice.
Give it this name. The reason
it's
they
clear to
call
me
it...
the aliens want to isolate us is what it is.
What is it, Brian?
The aliens want to isolate us.
Oh, right. Okay.
Yeah. The reason that we call it dark energy is because if you say, well, I'm going to measure how this expansion of the universe is speeding up, and I want to know what could cause it to expand and speed up at this rate, the answer is you've heard of the term 0 point energy, right? You take all the energy out of a system, you take it down to its lowest energy state. Sometimes in quantum mechanics, the 0 point energy of a system isn't zero. If you take an electron down to its ground state in the hydrogen atom, it's not at zero energy. It's at some minimum energy that's, some fraction of Planck's constant, but it's not zero.
Right.
It's mostly.
Well, it turns out if you take all the energy out of space, all the matter, all the radiation, everything out of it, you get some energy for how much energy is intrinsic to space itself. What's the 0 point energy of empty space? And the answer is it's not zero. Not zero, it can explain this accelerated expansion. And that's what we call dark energy, is this energy that's intrinsic to empty space itself. So that's dark energy. And what it means is if you obey the laws of physics and you say, I'm going to go and try to reach the farthest galaxy that I can, moving as close to the speed of light as I can. I'm not going to break it. I'm not going to break the laws of physics, but I'm going to go arbitrarily close to the speed of light. And I want to know if the universe is 46 billion light years in any direction, how far can I reach? And the answer is something that's about 15 to 16 billion light years away now is the limit of what you can reach. That the expansion of the universe is so great that that about 2/3 of the universe in any direction, you can't reach it. It's only that closest part to us. If you do your math and you say, well, how much volume of the universe can I reach? It's less than 4%. Wow. So 97% of what's out there in the universe, in the observable universe, is already unreachable to us thanks to dark energy. So if I heard you joke, Brian, that the universe, the aliens are trying to isolate us. They already did.
So that brings me down to back to the when I have discussions,
I need a drink.
When I have discussions about the creation of the universe, I now even think it makes less sense, because it's like I thought the universe was so big that it would be crazy to create all of that just for us, and I was 250 times less convinced of that as I am right now. I am now 250 times more convinced that it's not just for us.
Okay, so they just discovered a planet around the nearest star, right? That
sure
may be
did.
maybe Earth-like.
It might be. It might be. I mean, it depends
how long
on what
would
you
it
mean
take
by
to get
Earth-like,
there?
but I'll let you go.
Rocky, Goldilocks zone, maybe water.
Who knows, right?
That kind of thing.
But let's say,
So
Brian?
how close is this? What would it take for us to get there?
So the nearest star to us is very, very far for us. The people have written wonderful things, far better than anything I've ever written, about how mind-bogglingly empty space really is. So if you say, like, hey, we want to go to the moon, we've done pretty good with going to the moon. We can send the moon in like a few days, like 3 days, you can get a person to the moon. If you say, well, what about light? You can send light to the moon in just over a second. Well, the nearest star to us, Proxima Centauri, and the new planet that they think they found is called Proxima b.
Yep.
That's 4.24 light years away. So it would take a beam of light a little over 4 years to get there. So for someone, on Proxima B, they're watching, they're watching what's going on.
They're watching Friends.
Early 2012.
They're watching the Friends season finale.
That Obama guy is going to get reelected.
Oh, yeah.
That's what's going on over there.
Huh.
I hope they bring back Futurama. I hope.
Yes.
So these are some of the burning questions about
going
Earth
on.
for someone on Proxima.
Wait a minute, so they're still going, who are these humans? Right.
That's right. Donald Trump is just some orange jerk on the TV.
Yep.
Super different.
Right. Awesome. So
so that's how
fastest
far away it is. So if your question is, how do we get there? Well, for a human being to get there, right, we've got our current rocket technology, which is pretty lousy. With current rocket technology, it'll take tens of thousands, maybe even hundreds of thousands of years to get there. I'm going to say tens of thousands because for the next years or so, Proxima Centauri is actually getting closer to us. It's right now it's 4.24 light years away, and at its closest, it's going to get to just like 3 light years away. Wow. So if we can wait another few tens of thousands of years, we'll get a little bit of help.
Right.
Yeah.
But 3 light years is still a really long distance. We need new technology to get there. And so the most exciting technologies are, if I were to pick, like, realistically, how are humans going to do it? There's 2 real plans. One is this laser sail plan, where if you build a giant laser array in space and you build a giant sail that can reflect these lasers, you can the sail, accelerate it as fast as you can, and send it on its way. Now, we can get something theoretically that's like a sail that's maybe, 10 square meters. If we shine the laser array at that, and we have this sail with a little tiny microchip on it, have a mass of just, less than a gram, we can maybe get that sail up to 20% the speed of light. But you don't want to do that to a human in a spacecraft because you guys have heard of G-forces, right? That's acceleration, and you can't accelerate a human too fast, or the blood stops pumping through your body and the oxygen stops flowing through your body and you die.
Gradually build up to it and acclimate, I guess, but
that's the problem is lasers.
It still would.
Anyway, that's one possibility. There are technical challenges. People are working on it. The other possibility is to build an antimatter engine, right? Because normal rocket fuel, pardon my French, normal rocket fuel sucks, right? You bring a pound of rocket fuel on board, and you can get about 0.001% with the best fuel there is of that mass turned into energy to use for thrust.
Especially if you have to escape a gravity well, which is, because the fuel per pound, it's worse. So,
Right. So if you can bring antimatter there, antimatter is great because if you get a pound of antimatter and a pound of matter, you get 2 pounds, you get 200% efficiency because you just turn it into energy, E equals mc squared, there you go. In theory, it's the best way to do it. It's the best way to go. Now, we've made some incredible advances. We not only know how to produce antimatter, we can make neutral antihydrogen and trap those atoms for about 15 minutes at this point.
Ooh. Yeah. Well, we're getting there.
So, look, it's not everything, and they're like, well, how many atoms can you trap at once? And I'm like, well, 3. But you know what? That's 3 more than you used to be able to do, and you can do more than one simultaneously. So if you want, these advances are pretty rapid. So I'm going to say, if you really want to get human beings to another star system, antimatter technology or laser propulsion technology are probably the two best ways to go. I like antimatter technology better because they offer the possibility of stopping when you get to your destination, whereas the laser technology will boost you and get you there, and then you'll go.
Then you have to figure out some way of slowing down.
Well, there goes my life. That's it.
It's just gonna
talking about. I was gonna say talking about technology and how fast technology advances. 30 years ago, this right here wasn't even possible, even with a computer the size of a building. So technology goes pretty fast.
And yet we understand very little more about the brain than we did back then. So
we're getting there.
It depends on the domain.
We'll send a brain.
Yeah.
But robots. I mean, that's what I'm saying. We'll send all kinds of probes, and we can accelerate them to speeds that we can't handle. So yeah, let's do it. Let's populate the entire universe with robots and make us obsolete.
So if you manage to hit Proxima B, if you manage to hit this planet with one of these probes moving at 20% of the speed of light,
I know.
What would they think on Proxima B? What would we think on Earth if we got hit by something moving at that speed? We would think, oh no, the universe is sending these things that I don't know what they are to kill us. They're burning up in our atmosphere. They're making craters in the ground. We're under attack. We might start the first interstellar war because we're trying to explore the next star.
Andromeda strain? Was it?
That was a virus. That was a virus.
But it was a technological probe that actually, from our point of view, was an infectious disease.
Yeah.
So it was,
All right. So to keep things on schedule, because because we have another piece of the show we want to do tonight. I'd like to maybe move on to the game, and then Ethan, I could just talk to you all night. We could talk to you for days. We should have you back on. You want to come back on sometime?
That's a good idea. Let's see our calendars and let's schedule something, because this is fun, and you guys are keeping me from getting too serious. Right. I like it.
I mean, that's sort of that is honestly though that is sort of the mission of our show. We have our audience is a fun audience, and a lot of gamers and a lot of people into sci-fi and stuff like that, not always necessarily scientists. So we try to keep get into some really deep stuff, but not too deep, no equations, you know what I mean? Because it touches on one of the other things you want to talk about. And we can talk about that real quick is science outreach. I feel like part of our mission statement, and Mike and I have had talks about this many times, is science outreach. So we do it in our own way with fart jokes, but there are plenty of people who enjoy. No, well, seriously, there are plenty of people who
brown matter research.
Right. They enjoy their science with a little fart joke on it. So I think it helps. It's kind of like a sugar pill, right, Mike? Kind of brown.
Yep. A spoonful of fart jokes makes the
science. So what do you do, Ethan? For science outreach? What is
well, I mean, for you, if I had my chance, I would send you to Titan, Saturn's giant moon, because its atmosphere is almost 100% methane. Right. So that would, I would say that your farts would just blend right in over there. But what's also cool about that is because of methane is like a nice hydrocarbon, if you just brought Earth's atmosphere there, Earth's atmosphere would be rocket fuel because oxygen would combust with methane. So that's kind of a nice thought as well. What I do for science outreach, for me, and talking to me, I really believe that the story of the universe is not for just the people who study it professionally, that this is something that exists, that we are all a part of, that we all have the same universal common story, and it's for everyone to understand, be aware of, and appreciate, if we can just explain it to people in a way that they can understand it in their terms. And I think if we can't do that, then that's a failure on the scientist's part, not on the general public's part. So the things that I've been doing for that is really everything I can think of. I've been writing about the universe since 2008 on my blog, Starts With a Bang. Book. It's called Beyond the Galaxy. Just Google Beyond the Galaxy and my name, Ethan Siegel, or just Beyond the Galaxy. It's the #1 hit because hooray. And the book's available on Amazon. You can get an ebook if you're a fan of that. I think
hardcover, paperback, Kindle.
Mm-hmm.
Sorry,
Hardcover, paperback, Kindle. I think that the Kindle version is actually under $20, which is not bad. But it's the whole story. It's all of this, like everything we touched on: the birth of the universe, the size of the universe, dark matter, dark energy. This is all in the book, and it's all there with lots of illustrations. And I know because I made half of them.
Right.
And no equations. So if you like reading a story in plain English about where this all came from, how we know it, and what we're trying to do next, like I highly recommend it. My claim to fame is Adam Rees, the Nobel laureate, the guy who co-discoverer of dark energy. He uses this book in his Intro to Astronomy class.
Nice.
So
damn,
that's my big claim to fame.
That's a good claim.
It's pretty good.
Yeah.
So if you wanna, if you want some moderate reading, I won't say it's heavy reading. I think it's easier than The Elegant Universe,
Yeah.
Which is also good.
Right, it's good. No,
But,
Brian
but
Greene
it's
does
a
a good
little
job.
heavy.
But yeah,
But nothing in that book is speculative. Everything in this book is what's known and how we know it, and how if we lost all of human knowledge tomorrow, we could go find it out again. So this is I think pretty solid stuff. And I'm continuing to do more and more stuff. I appear on my local news every time they have me on to, which is probably about once every month or so nowadays, to go and talk about the latest space findings. I do a podcast once a month. I write a column for NASA. And yeah, like I think it's really important to get this story out there to the universe. And of course, I come on podcasts that do a whole variety of things anytime I'm invited, because this is a great chance to get out and spread the word and tell the story about what we know and how we know it. And I think this is really exciting. I think it's kind of funny how to most people I'm like super nobody. But every once in a while I'll meet someone and they're like, "Whoa, Ethan Siegel, you're like internet famous." And I'm like, I don't know what that means, but thank you. Like, that's great.
I'll tell you what, you got a fabulous, fabulous beard.
Well, thank you. Thank you. I like to think that if I lived anywhere other than the Portland, Oregon area, that my look would be unique.
Right. Right. So you can find.
Not if you go to a con.
Right, that's true. You can find all of Ethan's stuff here. I'm going to give you some links. So you can go to Forbes.com/sites/starts with a bang. You can find him on Facebook. It's Facebook. /starts with a bang. Twitter is @startswithabang. I'm starting to see a theme here. You can find him on YouTube.
Should have titled my book "Starts with a Bang."
Right. You can find him on YouTube /user/Ethan Siegel. He's also on medium.com /starts-with-a-bang. And you can find him on scienceblogs.com /starts-with-a-bang.
Not to be confused with starts with the umlaut.
Right.
Starts with an interrobang.
Right, interrobang. All right. So, Ethan, thanks for coming on the show, but stick around because Mike is going to run a game for us. And it's a fun game. We haven't done this in a long time, so I'm pretty excited. So, Mike, I am going to hand the show over to you, sir.
All right. Let me see if I can start this and do the thing with the share, like thusly.
Ooh, look at that.
See it? You good?
Mm-hmm.
All right. In case you needed to know, we, ladies and gentlemen, are going to play the MythWits Survey Says. And welcome to the new and improved MythWits Survey Says. I am your host, Michael Cthulhu Kafis. Survey Says is simple. 100 people have been surveyed online. These questions are geeky in nature, and you must do your best to guess the most popular answers to these survey questions. Each round, player order will be determined by a polyhedral random number generator. Pete, do you have a 6-sided polyhedral random number generator?
Why don't you do this? Hey, let's do this. Just pick who you want to go first, and then we'll go down the line.
That's fine. But then we'll go down the line, starting with Brian, Ethan, and then you. How's that?
Okay, sounds good to me.
All right. The player will attempt to guessing a survey answer. Each player will receive up to 2 opportunities. We'll just go round robin, and you can give your best survey answers. If your provided survey answer matches the one on the top recorded survey answers, you will receive that total in points. The player with the most points at the end of the 5 or more rounds. I'm not sure how many we're going to get to. This week's survey says Overlord. I think we're doing 5 or more. So, and there's something about a possible tie. So, basically, the only difference is that I will not be revealing the answer after each of your guests. That's why we're going to record everyone's answers and then go down the list.
Okay.
All right? So, starting with Brian going first on this round of round 1. Brian, name a popular spaceship series.
Firefly.
That is, you're recording these, Peter?
Mm-hmm.
Okay. Ethan.
Wait a minute.
Name.
So hold on. Just be clear. The spaceship name, right, Brian?
Serenity, then. Serenity.
Just want to make sure you
Yep.
understood. Okay.
Thanks for correcting me.
Right. You might. I'm just saying.
I lose geek points for that, don't I?
I don't know.
If it makes you feel better, Serenity is a Firefly.
Oh, okay.
That's true. See, that's what I was thinking.
All right.
Thanks.
Ethan, can you name a popular sci-fi or a popular spaceship from a sci-fi series?
I'm going to go with Enterprise.
Very good answer.
Mike, I'm going to go with Millennium Falcon.
The Millennium Falcon. All right. We're going to go. You may get one more guess because we do 2 rounds through.
What?
So, Brian.
What? Huh? Oh. What?
You get another guess. You get a second guess. We're going to do 2 each.
Oh, second guess. Well, I guess I can't pick one that you guys have already picked?
No.
That's correct.
Oh, wow. So, Voyager.
All right.
Which is not going to be one of the ones, but just the first one that came to mind.
Ethan.
I'm going to go with Battlestar. Battlestar Galactica.
Nice.
Yeah.
Okay.
And Peter.
Sci-fi ship, huh?
Ooh.
The Death Star.
I think Death Star is a good one. Death Star was what I was thinking, so I'll
go with Death Star.
Good for you for taking the one I almost took.
Do I get a third choice? Because I got a better one now.
No, this is it. All right, Mike.
All right. Here comes the reveal, ladies and gentlemen. The first most popular spaceship from a sci-fi series is TARDIS. Yes.
What?
TARDIS. The TARDIS. Hey.
I'm actually sad that I didn't.
You know, that's pretty good. You have to remember what he said. This survey was on the internet.
Yes.
That's true.
And you know what's great? We can redistribute these surveys, and we'll always have different answers every time. Wonderful people. So this particular survey, the TARDIS was. And number 2, ladies and gentlemen, is the Millennium Falcon.
For how much?
Way to go. Way to go, Pete.
Here with 23 points.
23, okay.
And number 3, Serenity.
Yay!
So someone else 16 points, huh?
Okay.
And number 4, the Enterprise. Ooh, there we go, Ethan. And number 5.
Hold on a minute. How much was the Enterprise?
That was 14 points, sir.
Okay.
And the 5th most popular spaceship from a sci-fi series. Top 5. Moya from Farscape, which I was quite shocked and yet pleased about.
Yeah.
See, I after you asked the questions, I thought of Heart of Gold, which is one of my favorites,
Yeah.
and Moya and Targus, which I'm slow.
Moya's my favorite. I just
That's
didn't think
okay.
it would be up there. I was playing for points.
Oh my god.
I am slow myself. So here we go on to round 2. Gentlemen, and Ethan, you will be going first. Please name
Serious now.
a popular 80s arcade video game.
Ooh.
Must be art. Now, let me just make sure everyone is understanding of this. This is an actual 80s arcade video game, one that would be in a cabinet at an arcade, not one that would have been, on an NES or some others, Sega Genesis or something else. So this was a. You're not that young, are you?
Okay.
What are you? You're 30s, right?
Yeah, I'm 38, so I was born in the 70s. So we had arcades where I was. I'm gonna go with the hardest video game of all and say Donkey Kong.
Donkey Kong. I like that. All right.
Yep.
That's a good one. Peter?
I'm gonna go with 80s. See, Space Invaders 70s, but it could have still been in arcades in the 80s. And then there's Pac-Man, but again, I'm gonna say Pac.
Are you just gonna give us all answers?
Oh, I'm sorry. I'm gonna go with Pac-Man. Never mind those other answers I gave.
I think you should just stick with the one that you come up with first. You took mine, damn it.
You go ahead and say I got Pac-Man. You can take the other one if you want.
You can take anyone you.
Well, I was thinking. One I used to love to play was Defender.
Defender. Ooh, you know what?
Yeah.
That was in my top 5.
Yeah.
Yes. And you're.
Fast and hard. Yeah. Oh yeah.
I used to actually.
And its brother Stargate, which was pre-other Stargate.
I think I ever played. All right, Ethan, your second round guess is.
All right. I need to make up some ground. I know I'm in last place here, so I'm going to go with one of my favorite games from my childhood, Double Dragon.
Ooh.
Double Dragon.
Nice.
I like that.
This is not me. I mean, I do know the answers, but I am guessing. I'm wondering, did Double Dragon come out in the 80s? Was that still in the late 80s? I'm not sure, but we will find.
Oh, it was not even late. It was like 86.
Okay. All right.
He knows.
All right, Mike. I'm gonna say Tetris.
Tetris.
Yeah.
Well, that's interesting and nice. And that's good. Okay. That's for the reveal, ladies and gentlemen.
Wait. Brian gets one more.
Hey, I get my second one.
Yeah, he gets a second.
Oh, I'm sorry.
Can I Google? No.
It won't help
to do
you.
It
for you.
won't help me at all. Let's see. There was a game. What else did I like to play? Well, can I say Donkey Kong Jr. because that was actually more fun than Donkey Kong?
It's a different game.
I mean, I would agree with you on that, but okay, that's fine.
Because if I can't have that, then I would say Jungle Hunt because I played the crap out of that game.
Oh, Jungle Hunt was so good.
Oh my god, that game was awesome.
So good.
I'm gonna go with Jungle Hunt,
Jungle Hunt. Okay.
which
All
is
right.
not gonna be on the list, but I liked it, so I'm just going with it.
That's all right. I honor you on that one, sir. All right, and the number one most popular 80s arcade video game for this particular survey was Galaga.
Oh my god, nobody
that's a
said
good one.
Galaga.
I thought of it.
And the number two most popular one, Pac-Man.
Yeah.
Nice.
Yep. Nice.
No, and at number three answer,
How much was that, Mike?
Pac-Man was for 15 points. I'm sorry, you know what? For the audio listeners, Galaga was for 17 points. Pac-Man was for 15 points. And number three, for 14 points, Space Invaders.
I
No. And
and I bet you the next one is Asteroids,
Asteroids was a good one.
which I didn't think of at the time, but yeah. Wow.
I would have said Asteroids, but somebody said Joust.
Joust.
Oh yeah.
Dude, I love Joust. I can't believe that was in the top 5.
Oh my god.
I
I can't believe I didn't think of that.
Yeah, this was amazing.
That ate so many of my quarters. It's crazy.
Indeed. For me, and I know this is not the last answer. Actually, I'm going to save it. All right, here's the last answer. Number 5, Hubert.
Oh, yeah.
Hey, Mike, do you have any idea how many people answered this survey? What was the final tally? Do you know?
It was about. It doesn't really matter. I think we were in or 90s, but the thing says 100 people. But since we go by the percentages anyway, I calculate the percentages, which is we said 100 people were serving at the beginning. So let's not ask that question.
Okay, all right, sorry. 100, right? That's what right. Okay.
There were error bars in the 100
the
people.
magic of Hollywood. Shut up. A lot of my quarters.
I asked the guy down the street, and
Tron. I played like that.
I know.
Yeah.
I didn't think that either, and I wasted so many quarters on Tron.
All right, and Kubert was for 10
Doodle-doo.
answers, 10 points, 10%. Anyway, can we get at the end of round 2? Can we get a score sheet there?
Yes, we can. All right, so I am in the lead with 38 points.
Of course.
Brian is coming in second at 16, and Ethan is at 14.
Is what?
At 14.
Okay. I would like to point out that
It's close. It's really close.
we post the, and I am the only one that gets sent this email.
Yes.
So the responses. So he does not and has not gotten these, but he is a gamer. He's a game theory. You are going to have to really rack your noggins a little bit.
Now, Mike, can I ask you what year were these answers from?
2016, my friend.
Okay.
We just did this.
So clearly, there were only respondents from our age group.
Could be.
Watch Ghosts. All right, here we go. Round 3, gentlemen, and the question is: name a popular Doctor Who actor. All right. Are we all knowledgeable enough about the actors' names of the Doctor Who's?
I am.
If not, if you're having issues, then you can certainly just give the actual doctor, or give a description. But Pete, you are in the number one guesser.
You know what? I am in the lead, so I'm going to take a chance because just on principle. This is a principle answer. I know he's not going to be number 1. He may not even be in the top 5, but I don't care. Tom Baker, my doctor.
See, he's my doctor as well. But I'm guessing that the top one. I don't know. Am I next?
Yes, you're next, Brian.
Because I presumed. I'm going to guess that the top doctor is going to be David Tennant.
Okay.
Because he's the current most popular.
All right. Current.
Yeah, that's a.
Yeah.
We'll see.
I like those guesses. I'm going to go with Matt Smith.
Okay.
I think Matt Smith is the doctor I'm going to have to go with.
I think that Tennant and Smith are neck and neck, as it were. But we shall find out shortly. But first, Peter, your second answer.
Well, I'm gonna stick with the doctors I like. I'm gonna go with Eccleston.
All right.
Destro.
That's great. Peter goes with Eccleston, and Brian, you are going with.
For my second guess, I'm going to go way out there and just say, because I like the really bad Fox movie, and I like the little bit he did for the 50th anniversary. Paul McGann.
Oh, nice.
Yeah.
What does the Fox say? Oh, never mind. Ethan.
All right. Now, I just want to be clear. Is it about your favorite doctor, or is it your favorite character?
It's who you think.
Does it have to be a doctor?
No, it has to be what doctor the audience picked. Or
what
people
doctor
who took
the audience?
whatever they picked, whatever the survey people picked. So a lot of times it's not the person you like at all.
But
So no, what I'm saying is it's not you can't pick a non-doctor person
No.
on the show.
you are correct. You cannot.
Okay.
The question was posed.
So has anyone said Capaldi?
No, they have not, sir. And is that
Well, we gotta go. I don't know. I don't know all the doctors, so I'm going with the one I know.
All right, very good.
Ian locked in with Capaldi? And are we done? Or is it?
Yep, that's it, Mike.
All right, here is the reveals, gentlemen. The number
Survey
one
says.
popular doctor. Show me David Tennant.
Booyah!
Good job.
Oh,
That's only because Peter didn't take him.
All right, how much?
for 35. That was actually a quite good amount. Yes.
Oh shit, that's a landslide. Okay, go ahead.
Yes, I know. All right, and Ethan, was Matt Smith. Let's see if Matt Smith is number 2 or not. Ooh. Tom Baker actually made it with 25 for the number 2.
Yeah.
Well done.
Damn.
All us old school Doctor Whoers, yeah.
Yeah, that had
Yeah.
to have been because I
Yeah.
thought for sure he wouldn't even be on our top
Oh.
5.
I don't
Come on.
I don't know.
I've been watching it since I was a kid, so.
Oh yeah, well,
yeah.
so
Tom
have
Baker's
I.
my doctor.
I'm just saying. I didn't think the people who taken the survey. I just assumed it would be one of the new ones. But that's great. That's good. Yay!
I'm hoping for you, Ethan, that Matt Smith is number 3. Show me Matt Smith. Oh my God, Christopher Eccleston. What is going on with these
Ooh.
people? They must be some Matt Smith haters.
What is that, Mike?
That is Christopher Eccleston for 14 points.
Jeez, how is he in the top 5? I mean, I like him. He had one season, right?
He had one, and he's so badmouthed the whole Doctor Who thing after the fact.
I know.
Oh my God.
All right.
So people don't know about that. They just, well, you know what? They base it on his acting merit, on his work. So that's good for them. I couldn't do that. Okay.
He will always be a dark elf to me.
Yes.
Interesting. All right. So the number 4 answer for the most popular Doctor Who is, there he is, Matt Smith for 12 points.
All right.
They're so geez. I mean,
I'm hanging in there.
Are we going to go? What do you guys think? Is this Capaldi? All right, Pete. Of the answers that haven't been read that have been submitted, what do we have left?
Paul McGain and Capaldi, and I can almost guarantee Paul McGain's not going to be on it. It can't be, right,
No.
Brian?
No.
There's no
Not
way.
even a chance.
If he is, I'm gonna
He's
shit.
like one of my. I know. I have a personal thing with Paul McGain, and that's kind of the only reason I even mentioned him. So.
All right. So this is the last one. I'm going to say it. I'm going to do it the opposite. I'm going to say, show me Capaldi. Oh, yes. There it is for 11 points.
Nice.
Very good.
The only thing about Capaldi is he doesn't cuss enough.
Oh, you're watching the wrong show, buddy.
I know.
All right, so Mike, do we want
To all those other sailor doctors, right?
Do we want to what, bud?
Do we want to? We're getting close on time here. We're hitting about 1:28.
Yeah, and you wanted to do 10 of these, remember?
No, not in one. No, not in one game. No.
All right. What have we done? We've done 3.
Yep.
Do you want to do an even 4?
Sure. Why not?
Or do you want to?
Hey, let's.
Okay, we're gonna do one.
Let's do an even 4, and since Ethan is at the bottom of the list, we'll let him go first, and then Brian is second, and then I'm last.
All right. That sounds good. And our question, gentlemen, is name a popular Jedi Master. What? Any Star Wars fans out there?
I'm gonna go with Master Yoda.
Okay.
Master Yoda. I think he would have to be. He would definitely be popular. You know how like, sometimes when you give these kind of surveys and you are going to get someone who's just going to go way out the left field and give somebody from some like the not even the canon. Oh, I'm going to say Master Shidugi, and but that's not this case. But I think that was a good answer, Peter.
No, Brian's next.
Oh
No.
Brian next.
Yeah.
Yep.
Well, I'm always partial to the badass Mace Windu.
Windu's good.
Yes, Windu is good.
The only one with the purple lightsaber.
Okay.
He's only this bad motherfucker. Too.
Bad motherfucking Jedi.
All right, Peter.
Shit. See, this is Jedi, so it's not Darths, right? Darths don't count. It's got to be Jedi.
Nope.
Unless they would have had to have been a Jedi Master within the Star Wars universe.
But it would have to be that name, right?
So with the person's name, not the Darth version,
not
because
the
that
Darth
would.
No,
version.
you
Okay.
can't have Jar Jar Binks. I'm sorry.
Sorry, right. Yay. Hey. I'll go with, you know what? I'll take it easy. I'll go with Luke Skywalker.
Nice. I had to double confirm that he could be considered a Jedi Master.
I know. I was thinking about that.
Yeah, I know, but no, it is because within the expanded Star Wars universe, he is a master at a certain point. Even though, like,
Well, you
thrown out
could
now.
watch the most recent movie
Yeah,
where
Mike-
he is the master.
Mike, he is like the master in the latest movie. You see,
That
He is so much a master that he doesn't have to speak.
no.
Right.
He became he became a master. Believe it or not, you guys, at the end of Return of the Jedi,
Oh, I know.
because
Because he kissed his sister?
okay,
Oh God,
no, that
nice.
was
I didn't know
Hey,
about these.
Wait a minute, Brian. That only works.
initiation
That only
routines.
works on Game of Thrones.
Oh, okay.
All right, Mike. Come on,
I was confused.
Peter or
Ethan.
what's his?
I get confused. People confuse me with Vader all the time. I get it. But Vader is only a master of evil as opposed to Obi-Wan, who is my choice for the master.
Oh, yeah.
Jedi Master Obi-Wan Kenobi.
Love me some Obi-Wan.
Old Ben.
Ben. All right, and Brian.
I get a second.
Yes.
Yes.
Mm-hmm. All the good ones are taken.
Gosh, there's a couple of actors out there going.
Yeah. That's that Anakin guy.
You
want
can
the
go with the Anakin guy.
My
He was-
Anakin guy.
He was a master for a brief while.
Yeah, he was an honorary master because they kind of forced him into it. Okay, fine. Anakin,
All right.
because it's not going to win anything. Because everybody hates him.
Right.
He's so annoying
Right.
and whiny. He's like more whiny than his kids.
He is. All right, Mike.
I think it was the act.
So is it required to be whiny to be a Jedi? I don't.
To be a Skywalker.
No, it's only
No.
required if you're a boy Jedi.
Right.
If you watch the new movie, you will see that the new Jedi is not whiny.
That's true. She is
Well,
not.
didn't need a master yet, and neither is the oh, never mind. Forget it.
What you didn't pick, the one that you're hoping Pete doesn't think of.
So, Mike,
Yes.
I'm gonna go.
Never mind. Go
I'm
ahead.
gonna go with Qui-Gon. Qui-Gon Jinn.
They're a good answer.
Qui-Gon Jinn.
Qui-Gon Jinn.
Yep.
That's right. Everyone just wants.
Yes. Qui-Gon Gin and tonic.
Right? That's why I like him. He's tasty.
Slice of lemon.
You took Anakin to the dark side. I will find you, and I will kill you. Okay. Anyway.
He was so good in that fight with Batman
take
on the
it.
tree.
Right.
Yes. Yes, he was.
That was my. Never mind. All right. If you don't get it, you just don't get it. The reveal,
I got
ladies
it.
and gentlemen. Number one, the most popular Jedi Master, Yoda, of course.
Of course.
Excellent.
Oh yeah.
We're 33.
Yeah.
Full
Jesus.
rank.
33 points. God damn. All right.
No.
That is.
That was
Wow.
a gift you gave me by letting me go first.
Yeah. Well, you were the lowest, so I went with that. Yep.
You were at a low, and now you're at a high.
Right.
Speaking of high, show me number two. Obi-Wan Kenobi.
Ah.
Who was this Obi-Wan?
That was Ethan.
Oh, Ethan
Yeah.
for 20. No. All
Yeah.
right.
So another a 20.
All right.
Stomping.
You said 20, Mike.
I'm sorry, Pete.
20?
That was for 20 points.
Damn.
Yes,
All
sir.
right.
20.
20 points.
Got
Was it 20 points?
Yes, it was. All right.
20, yeah, it's 20. Yeah, okay.
Yes.
20 then.
Hey, Brian.
2-0.
20
If
points.
I pull this out, I'm going to dedicate this win to Capaldi.
There you go. Nice.
He fucking deserves it.
All right, Mike. Who's number 3?
Number 3. That was awesome. Mace Windu.
Woo! Really? Mace Windu was 3?
Mace Windu is number 3 at 19.
Wow.
Nice.
Just a scant 1
That
less
was-
person behind Obi-Wan Kenobi.
Yeah, that was higher than I expected him to be.
Okay.
I know. And the number 4, Kit Fisto. What?
What?
You know, you said that there would be someone that was only on camera
I
on the internet. Just there you go.
And, you know, I totally played Kit Fisto in one of the games. I don't remember, but
He's the coolest
Sorry.
looking.
yeah.
Well, I mean, 11 points. So we did have our troll contingent,
Right.
of the internet chime in. And okay, so Peter.
Yep.
We have Yoda, Obi-Wan, Mace Windu, Kit Fisto, and at number 5. And of what of our submissions have not been chosen yet?
Anakin, Luke, and Qui-Gon.
Luke or Qui-Gon? Ethan, just for shits and giggles, of those 3, which one do you think will be number 5?
I'm going to go with Qui-Gon. Master Qui-Gon.
Yeah.
Show me Qui-Gon.
No love for the Skywalkers.
That was actually it. That was it. I'm sorry, I hit the button twice. So yes, sorry. Bing bing. Yes.
Qui-Gon.
that was
For how much?
That was- I don't know. I'll have to unshare and check that points for you because I don't want to reveal on the screen.
I can't. We can't see the screen, Mike. By the way, we've been seeing you.
We can?
No.
Yep.
Yeah.
What?
Yeah. We've
Oh,
been
that's a load of crap.
We're good. We're good at playing games. It's all a game. For all we know, you're making these numbers and these answers up. It's fine.
It's
Wow.
fine.
You're like, oh yeah,
Actually, I
Capaldi, he
think
was
we're
a doctor, wasn't he? It's fine.
Man, ain't that some shit? Hey, there you go.
Oh, there he is.
Hey!
Oh, hey. How about that? Welcome to the show. All right.
Wow, that's
Essentially,
pretty.
what you're saying is I've been playing with myself. Is that what
Yeah.
we're? I mean, that's
I don't know how it got
Wow.
off the
All right.
share screen.
I think
so.
All right.
Ever since the beginning, it hasn't been on the share screen.
No, I didn't know
Yeah.
if there was something that you couldn't do or something. I didn't want to break the stream of the show, but it was there and then it wasn't.
Wow. Well, there you have it, ladies and gentlemen.
The TechWits!
Breaking. Well, at least I have proof that I actually had this whole thing all ready to go. So
we appreciate your thing.
yes, I was playing with it the whole time. You guys didn't know.
Oh, shit.
Pete,
Yes,
I got
sir.
Jim with 7. Please, how do you stop this crazy thing?
All right, hold on.
Choose a
Jane,
winner.
All right, so we have that, and then I think I'm going to have to say, I think Ethan is the winner, but hold on, I'm adding it up real quick right now.
All right, as he's adding that up, I will say that Master Yoda told Luke Skywalker that he would only be a Jedi Master when he faced Vader. So when he confronted Vader in the Death Star and succeeded, quote unquote, that's when he became a
All
master.
right, I'm ready. I'm ready to do the reveal here.
say,
All right, and we're going to do this in reverse order. Brian, you take
Yeah.
up our third spot with 70 points. Yay, 70. I take up the second spot for 84 points, which makes Ethan our winner with 90 points. He pulled it out
I
from
feel
the
like
rear.
a winner. Would not have got there without Capaldi, so thank you, buddy.
Yay.
Congratulations. This week's the hell is this game called again?
Survey says.
Says Overlord. How does it feel to be the Survey Says Overlord? Ethan?
It's the greatest feeling in the entire universe.
Awesome.
Just
All right.
make sure your minions have clear plexiglass helmets.
Yes. All right. Well, we have kept you guys longer than we had said we would, so we're going to end the show now. Ethan, thanks for coming on the show. And if you're catching the game portion of this show, because we split this into 2 pieces, make sure to go check out Ethan at Forbes.com, sites starts with a bang, Facebook starts with a bang, Twitter starts with a bang, start YouTube Ethan Siegel, medium.com starts with a bang, and scienceblogs.com, guess what, starts with a bang. Ethan is an astrophysicist. If you missed the first part of our show, if you did, go back and listen to that. Mike, I is gonna run the closer and do this thing right here with there we go. All right, you've just enjoyed another awesome episode of the MythWits. A special thanks goes out to guest host Brian Gregory, and our guest tonight, Ethan Siegel. Make sure to check out his website and buy his book. What's the name of your book again, Ethan?
Book is Beyond the Galaxy.
Beyond the Galaxy. Join us for a live broadcast every week, Mondays at 9:30 p.m. Eastern Time to catch the full show. Jump into the chat room and ask questions. We had a guy in the chat room, but it kind of went by real quick. If you miss our live show, you can always catch the encore episodes and the podcast version on our website and on iTunes. We are part of the TSR Podcast Network, and you can find us at mythwits.com and tsrpn.com, dang on it. You can visit us on Facebook, we're the MythWits, Twitter, @MythWits, and on YouTube, /MythWits. Do the like, follow, subscribe thing wherever it's appropriate. Please give us a bunch of stars and reviews on iTunes. It's important. MythWits is a Stu187.com production. It's protected under Creative Commons license. Please don't steal it, but you can share it and download it and all that good stuff. Don't try to make money with it, because we don't. And that way you can't either. Make sure to check out Stu187.com for more cool stuff and join our mailing list. It's right on the front page. Hit the button. This episode will be edited into 2 pieces, the game show and the interview, and released next week, Monday and Friday, respectively. Thanks, everybody, for listening. Tell your friends to tune in. And until next week, Mike?
Hey, Mom, stop dipping in my Kool-Aid, man.
And